This is the demonstration on how to manage keys in Jellyfish continued. Next, I will show key generation using entropy or randomness from the HSM. In Jellyfish, this is referred to as soft key generation. A use case for this can be when you need the keys to be returned to the device requesting them, but the generation process needs to be FIPS compliant, or to at least use FIPS compliant hardware for generation. In this case, we have a keygen configuration option that lists your current key configuration. I'm going to create a new one as an example. And select elliptic curve key generation with the P384 NIS curve. There are a few more curves you can choose from. We'll generate it and it will show up in the list. Next, we'll navigate to Crypto Tools and then generate key pair. Select our new configuration here and click Generate. This returns a private key, a public key, a OID representing the algorithm and key length. This endpoint is usually used through the API if you have a system that needs secure key generation to function. Another configuration type is a signer configuration. This configuration allows you to specify certain parameters and behaviors in Jellyfish that you can use to perform digital signatures. Let's create a new one now and call it Demo Signer Config 1. Select the algorithm. Try RSA this time. The data structure can be either a PDF document, a simple digest, or even an e-passport structure. I'll select digest. This option here allows you to specify whether the data was hashed before sending the request, or if Jellyfish requires hashing to be performed before signing. I'm going to request Jellyfish to hash for me before the signature. It'll be RSA with SHA 384. Next, select the key. You can select the key to perform the signing. In this case, I will select Demo Key 01. You can also configure key rotation. If you want a config to be used often, you can set a maximum number of signings per key, and Jellyfish will automatically rotate which key is performing the signatures. For example, I can select the second key here and set the maximum number of signings to 50,000. This means if you use this configuration with Demo Key 01 to perform signatures, once 50,000 signatures have been generated, the key will be rotated and all future signatures will use Demo Key 02. The use case for this is for large amounts of signing with a single key. There can be security implications where information can be leaked, so we recommend not signing too often with a single key. 50,000 is a good limit to use. Select Create. As an example to test this config, there's a UI tool in the Tools menu, in Crypto Tools, and then Sign Validate. This is a demo example that allows you to sign some text, but realistically you would be using this through the API endpoint, which allows you to sign larger amounts of data and different kinds of data structures. I'll select my signer config and assign a simple message. Select Sign. You can see the signature was successfully generated. I'm going to copy it as an example and attempt to validate it immediately. You can see that it validates. If we change the message slightly, for example, by removing the exclamation point, the validation will fail. This is only an example. Realistically, you would be using this on a larger scale through the API. Another option is encryption, which can also be done through the API. I'm first going to generate a symmetric key of AES underscore 256. I'll give it a name and select the Lunar partition. Navigate back to Tools, Crypto Tools, and Encrypt Decrypt. We'll try to find the key we just generated. There it is. We'll encrypt a message. As you can see, that encrypted successfully, and this is the ciphertext. If you would like to decrypt it later, you can select the same key, paste the ciphertext, and you will receive the plain text. Realistically, HSMs are not best suited devices for large data encryption. They're mainly used for signing and verification, but can be used for encryption depending on your use case.